Hey guys, welcome to the beginning of section 5.2 called Properties of Rational Exponents and Radicals. This video is just going to get us dipping our toes into using the properties of rational exponents. So our learning target is I can apply the properties of rational exponents to simplify expressions. In the past, you have used properties of integer exponents to simplify and evaluate expression. These properties are the same for rational exponents. The only difference is, guys, we're going to be dealing with fractions. So here we go. Properties of rational exponents. For all non-zero real numbers a and b and rational numbers m and n, we have the product of powers property. To multiply powers with the same base, we add the exponent. So if I have a to the m times a to the n, that is a to the m plus n. Now again, I know these should be very simple. We've done these before. So I have 12 to the 1/2 times 12 to the 3/2. So I have the same base of 12, which means I just need to add those exponents. So that would be 12 to the 1/2 plus 3/2. Now remember, to add fractions, they just have to have a common denominator. And these do have a common denominator of 2. So I have 1/2, and then I have 3 more halves, which results in 4 halves. So that is 12 to the 4 halves. And when we can simplify numerical expressions, we will always want to. Well, 4 divided by 2 is 2. So that's 12 squared. And we know 12 squared is 144. Okay, let's move on to the quotient of powers property. To divide powers with the same base, subtract the exponents. So a to the m divided by a to the n will result in a to the m minus n. So I have 125 to the 2/3 divided by 125 to the 1/3. So that means I could write this as 125 to the 2/3 minus 1/3. Now to subtract fractions, we need the same denominator. And again, these do have the same denominator. So 2/3 minus 1/3 is just 1/3. So I could write this as 125 to the 1/3. And then we should remember of our previous lesson, we could write the 1/3 power as a root. That's the same thing as taking the cube root of 125. And we know the cube root of 125 is 5. So always, always, always simplify as far as possible. Moving on to power of a power property, to raise one power to another, we multiply the exponents. So a to the m raised to the n is a to the m times n. So 8 to the 2/3 cubed, we can say 8 to the 2/3 times 3. Now that's 3 over 1 if you would like to do that. You could cross cancel the 3's, or you could just multiply straight across and say, hey, that's 8 to the 2 times 3 is 6, and 3 times 1 is 3, and 6 divided by 3 is 2, so that's 8 squared, and that is 64. Okay, negative power property. When a number is raised to a negative power, it is equal to its reciprocal raised to the positive or opposite power. So if I have a to the negative m, that's the same thing as 1 over a to the positive m, or a over b to the negative m is the same thing as b over a to the positive m. So let's look at this. We have a couple examples here. We have 16 to the negative 1/2. Well, remember that's the same thing as the reciprocal raised to the positive power. So that's 1 over 16 to the 1/2. So we can apply that 1/2 power to both of those separately. Remember that 1/2 power is the same thing as square root. So that's the square root of 1 over the square root of 16. And the square root of 1 is just 1, and the square root of 16 is 4. So that's actually 1/4. For the next one, I have 1 over 64 to the negative 5/3. So when I do the reciprocal there, that's just 64 to the positive 5/3. Now I'm going to use the definition of a rational exponent and change this to a radical. So 5 would be my power, 3 would be my root, and I asked myself, could I take the cube root of 64? And I can, so I want to write that as taking the root first. So the cube root is 64, and put that in parentheses and raise that to the 5th power. The cube root of 64 is 4. I'm going to take that to the 5th. It's okay to use your calculator. 4 to the 5th power is 1024. And we are almost done. 2 more properties. The power of a product property. To find a power of a product, distribute the exponent. So we have a times b in parentheses to the m. That's equivalent to a to the m times b to the m. Okay, so in the example, I have 16 times 25 to the 1/2 power. Now, you probably don't know what 16 times 25 is off the top of your head, but you do see that it's a product being raised to a specific exponent. So we could write them as 16 to the 1/2 times 25 to the 1/2. And knowing that 1/2 means square root, this makes our problem much easier. That's the square root of 16 times the square root of 25. So that's 4 times 5, and that is 20. And finally, the power of a quotient property. To find the power of a quotient, distribute the exponent. So similar to the power of a product, this is just division. I will have a divided by b, all raised to the m power, is the same thing as a to the m over b to the m. So when I have this 16 over 81 to the 1/4, I can write that as 16 to the 1/4 divided by 81 to the 1/4. And remember, 1/4 power is the same thing as taking the 4th root. So if I write that, let's see, 16 is a perfect power it does have a perfect 4th root. It is 2. 2 to the 4th power gives us 16. And also 81, its 4th root is 3. So that answer there is 2/3. Okay, guys, that's just an introduction to the properties, and we'll practice more with them tomorrow. Have a great night.